Notice it says check your calculator at the door. These forms are these are forms that we've gone over. If you look at this right here, do you see how I have something squared? Alright, so right here, I have something squared. Right here, I have something squared. And the square root of this, which is a, and the square root of this, which is b, times each other, times 2, is my middle term. This is called a perfect square. We've talked about these forms. And how does it look in the beginning? A plus b squared. Right? So we've talked about how I can take this and I can factor it really quick. Or I can have, this is factored form, and this is standard form. We've talked about how I can go from factored form to standard form really quick, and how I can go from standard form back to factored form. In fact, that's going to be a huge part of these next couple of lessons, is that factoring idea. You with me? This right here is also a perfect square. Both of those top two are perfect squares. What's the difference between this one and this one? This sign is a plus sign, this sign is a minus sign, and notice this is the only difference. The plus sign right here, and the minus sign right there. Alright, what was the third one called? Oh my gosh. Told you this thing hates me. Alright, what's the next one called? Perfect. It's called difference of squares. And this is the form that it takes every single time. Right? We got something squared times something squared minus something squared, and it takes this form. Again, this is this over here is standard form, and this over here is factored form. All right. Notice here we have all our cubes, and these are the different forms that you need to have. What's the difference between this form right here and this form right here? This whole thing, a plus b, is the whole thing is cubed. Where in this one, I have a cubed and then I have b cubed. What does this one actually mean? It really means a plus b times a plus b times a plus b. Well, let's just cover this guy up for just a second. Pretend like my hand, right, is over this. Okay? Do you see how this is squared? Well, what is this right here? Isn't that like I took this and I have the perfect square from this form up here? Right? That's that part. And what's left over? A plus b. So really, is this anything, any new form that you have to memorize? No, you just have to remember that it's a plus b. I can rewrite it as a plus b squared. And I can follow this form that I have right here for my perfect square, and then I just have an a plus b left over. Is everybody following me? Evan, you with me? Okay. Now, same thing for this one. Right? Same thing for this one. Except now I have the subtraction sign, so I need to notice where my subtraction signs pop up. Now, why is this one totally different? Because it's not a plus b and that whole thing cubed. I don't have 3 bubbles like this. When I have this, I have these forms pop up, and we did these in class. We didn't really cover these. We didn't ever cover these forms because they're nothing new. Are you with me? They're just doing the squared version first and then leaving that a plus b that's alone by itself. Right here, this is a total different form, and what we did is, if I had x cubed plus 8, we realized, wait, that's x cubed plus 2 cubed, The reason I need that is because I need my A and I need my B, and we would just fill in all these different spots. You with me? So it would be x plus 2, and then it would be x squared minus 2x plus 4. Right? That's how we would take that form and factor. Take this guy right here and factor. We've talked about that. And again, it's going to be a big part of, chapter 5, chapter 6, or wherever we go from here on out. So how can we use this with a number like, if they ask me to do 46 squared. They said take 46 squared. I'm not going to, we'll do it right down here. We'll talk about this too. If we did 46 squared, does everybody realize I can break that up into 40 plus 6 squared? Have I broken any mathematics rules? Because what am I supposed to do first before I square? Parentheses. So what's 40 plus 6? 46 and then squared. So are these two the same thing? Just change the way it looked, right? Well, if I go back to my perfect square, do you see how I have A right here? I have A plus B squared, and then they gave me what it should look like, the form. Are you with me? What is this? A. What is this? B. And don't I have it something squared? So, can I follow what that form says? Which it says, that turns into A squared, which is 40 squared, plus A times B times 2, correct? Yes? Or I can do that, I can rewrite that if you'd like it this way. 2 times A times B, that's fine. 2AB plus what's the final one? What does it say? B squared, which is going to be 6 squared. Everybody follow that from right here. That pattern is happening from these guys up top, which mine's all written on, but I can erase it. A plus B squared is the same thing as if you take A squared, add 2 times AB, and add B squared. You following me? So we're trying to do this now. The reason that this works is because, yes, I understand. What does this really mean? It really means 46 times 46. That's what something squared means, right? And you can do it the old school way of 6 times 6, and then put that third, bring the 3 up here. 6 times 4 is 24, right? Plus 3 is 27. Placeholder 0. You can do it the old school way. But I've got a lot to remember. And if I was trying to do this in my head, it's going to be difficult to do that. Whereas these numbers are going to be prettier and easier to work with. Here's what I mean. 40 squared. Well, what you can do is just 4 times 4 is what? 16. But I had, how many zeros did I leave off? So I got to move that decimal twice. You see how I did that in my head without straining? That cashier would be freaking out right now. Okay? I would not, I guess 40 times 2 is 80. 80 times 6 is, 6 times 8 is 48. And throw that 0 back there. Plus 36. Well, a 0 plus 6 is, and 0 plus 8 plus 3 is, carry a 1. 6 plus 4 is 10, plus 1 is, do I have any hundreds over here? So that's just 11. carry my 1. 1 plus 1 is 2. There's no thousands place here or here, so it's just 2,116. That's how you can use your perfect square model to help with mental math, so you don't have to put in a calculator, so you don't have to take this and write it fully out, do all that. I'm going to expect you to do one of these on the test on Monday. This way. You will have to show work. If you just put this down as an answer, I'm marking it completely wrong. Did everyone hear that? I'm going to repeat it. It's even on the video. So I have proof. If you put this number down without showing this work, it will be marked completely wrong. Not partial credit, not anything. Wrong. You must show your work. I want to see that you understand this concept. It's not about the answer. It's about the concept. Because I know that you can just put 46 times 46 in your calculator. I am confident that every one of you can do that. Well, 98% of you can do that. There are some of you that will just find a way to make a mistake. I've seen your tests. All right. For homework, you're going to try all these problems number 2. You're going to try A, you're going to try B, and you're going to try C, and that's what I said. I'll put up the answers tomorrow in class. I want to make sure we understand how we got there. All right. Last type of problem that's going to be on your test. Remember Pythagorean triples is a set of 3 positive integers such that a squared plus b squared equals c squared. So, they're nice, pretty numbers that work out. Remember in Pythagorean theorem, it was a triangle. It was a right triangle. And this was A, this was B, this was C. For some of you, it's geometry and it's bringing back nightmares. For some of you, it's geometry and bringing back sunshine and flowers. So a squared plus b squared equals c squared, right? That was a Pythagorean triple, whereas when the numbers worked out really nice and easy. Can you put any number in for A and any number in for B and get a C out? Yes. It just might not be a very pretty number. It might look more like you guys. Okay? Remember, when I refer to nice and pretty numbers, I refer to looking more like me. Okay? So, if I had things like these is called a Pythagorean triple. It's one they use often because it's the smaller numbers and it's the one that's easiest, like the first one. How do I know this works out? 3 squared plus 4 squared equals 5 squared. 6, whoops, my brain got going too fast. 9 plus 16 equals 25. 25 equals 25. Check. That is a Pythagorean triple. You remember these? If I look at this one, is this a Pythagorean triple? 4 squared plus 5 squared equals 9 squared. 16 plus 25, is that going to be anywhere close to 81? No, it's not. So it's not a Pythagorean triple. Is this going to be a Pythagorean triple? Is this one going to be a Pythagorean triple? You don't even have to do any math. Why? No. They don't have to be in order. They don't have to necessarily give them in order. You could do 0.3 squared plus 0.4 squared. Does that equal 0.5 squared? Yes. What does that say? Positive what? Integers. Really, it actually should just, that's stupid. In fact, that irritates me. Stupid book. Shouldn't say integers. What should it say? Huh? Natural numbers. Because what does the natural number system start with? 1, 2, 3, 4, ... So actually, if they wanted to be a little bit more correct, they should have just said Pythagorean triples is the set of natural numbers, a, b, and c, such that a squared plus b squared equals c squared. You following me? What's the only difference between integers and natural numbers? There's negatives. What did they put out here? Hello. We can get rid of all those negatives by not calling it integers. And we can't have 0, right? You can't have a 0 side. That wouldn't be a triangle, right? So we got to get rid of 0. What number system would I be in? My naturals. See, sometimes you can be smarter than the book. With me? All right. So are these a Pythagorean triple? No. Why? They're not natural. All right. Here's the last thing we're going to go over. Let's see its formula. Here's what this guy said. If you use this formula, you can come up with any set of Pythagorean triple. All you have to do is have two numbers. That's it. And you can make a Pythagorean triple from using those two numbers in this formula. Don't make it more than it needs to be. But here's the big thing. When you have two numbers, one of them has to be bigger than the other, correct? Well, every time that you do that, do you see R and S? R is always going to be the bigger number. So like down here, we're going to do this one. We're going to do this one. 4 and 7. I'm going to do it closer to up here, though, so we can talk about where these numbers are coming from. 4 and 7 are the numbers we're using. Are you with me? What one is going to be R? 7. Why? There we go. So I'm going to do 7 squared plus 4 squared squared equals 7 squared minus 4 squared squared plus 2 times 7 times 4 squared. Everybody see where I got all those numbers from? Notice, what was the first thing that I did? Here's the other thing, like up here. What was the first thing I did? All I did is plugged in. Did I do any math? How many of you try to plug in and do the math all at the same time? Probably a lot of you. And that's where you make your mistakes. Same with this right here. If I go back to this problem up here, where I did this, do you notice what was the first thing I did? I just filled in. Do I know do I know that 6 squared is 36? Did I write that there though? Because I was focusing all my energy on taking this and changing it to this form. I didn't want to waste any of my energy focusing on something that I wasn't trying to do yet. That wasn't the step I was at. Too many times I see you guys trying to go too fast and you make these silly mistakes. You've only got so much brain power. For a lot of you, it's not that much. Do not try to combine too many steps. Notice, take your time. Take your time. When I did this, I didn't add that, did I? I took this right here. I took this guy, and I found out what it equaled. I took this guy, and I found out what it equaled. I took this guy, I found out what it equaled. Then I took another step, and I added them all together. You'll notice, I still make mistakes, but I make far less mistakes because I do that kind of stuff. I take my time. Same thing here. Notice what I did. I didn't try to square anything. I just plugged it in the original format the way that it looked. Now I'm going to start doing some math, and again, I'm not going to do too much. Right here, what do I need to take care of? 7 squared, which is, notice I'm not going to add, what's 4 squared, not 8, 16. I'm not adding those yet, am I? I'm not on that step. Squared equals 7 squared is 49 minus 16 squared plus. Now, I can do these, right? Most of you are going to, because 2 is right next to 7, you're going to go 2 times 7 is 14. And then you're going to go 14 times 4. I need my calculator. Okay? Some of you can do it in your head. But here's a better way. The better way is to use your commutative property and go, you know what? I don't know what 14 times 4 is like that. But what is 2 times 4? And what's 8 times 7? Isn't that much easier to figure out that that's 56 that way? That's, again, using the math so it helps you out. Okay, here's another strategy that they're actually teaching. Like my son is doing this strategy and he's in 1st grade. Some of you guys will seriously sit here and go, 6 plus 9, okay, 15, is it the 17 or 15? Okay, here's what's called making tens. Do you see that this could become a 50 really quick? Just by taking one of these from it, right? So if I make this a 50, what does that make this become? 15. What's 50 plus 15? Do you see how that's even easier to add that way than the old school way? That's called making tens. Equals 49 minus 16. Well, 9 minus 6 is 3. 4 minus 1 is 3. There's no, that one's pretty straightforward. No trick part on that one. So what did I find out? Do you see I have what is my A? 33. What is my B? 56. And what is my C? That's my Pythagorean triple made by using 7 and 4. That's the answer they're looking for. They want the Pythagorean triple. Which means if you took 33 squared, added it to 56 squared, you're going to get the same thing as 65 squared. And we generated that number, those numbers, by using this formula. You with me? Questions on it? So for homework, you should try. Just a second, I will. You should try B and C. We did A. Now look, think about this. When I did 4 and 7, were my numbers fairly large? What do you think is going to happen when I use 5 and 11? They're probably going to be pretty large. And when I use 15 and 20, they're going to be very big. Don't just go right to your calculator. Try to do some mental math. A lot of you guys are mental anyways.
You said the 33 is C.
No. This is my C. Remember, they can give you the Pythagorean triple down here in any order that they want. What one is always going to be the C? The largest. I just happen to put it in order down here, but even when the book gives you, like the ones that you check up here, that's not in order, right? What one is your C? The 89. Does it matter which one's A or which one's B? Well, they're going to be on the same side.